Hi everyone, in today's lesson we're going to be talking about how to solve quadratic equations by doing operations like taking square roots. So the first thing you want to do is to make sure you get rid of any numbers that are around the squared term or the squared expression. So it's either you're adding or subtracting or you're multiplying or dividing constants in order to get the squared expression by itself. And then the last thing you do is take the square root of both sides and then solve for x. So the first example here, you're asked to solve for x squared equal to 49. And in order to undo the square, we need to take the square root of both sides because this squared part is already by itself. So we're going to take the square root of both sides. And then we're going to have x is equal to 7. Now, usually, because this is a quadratic equation, you should get two solutions. And that's because if I take 7 squared, I'm going to get 49. If I also do negative 7 squared, I'm also going to get 49. So your solution should actually be x equals 7 or x equal to negative 7. Or you can write it as x is equal to positive or negative 7. Okay. Now in this example right here, this squared part is already by itself, so we're going to take the square root of both sides to undo the square. So you're going to have x minus 8 is equal to, well, technically there's no positive or negative 0, so we're just going to have x minus 8 equals 0. We're going to add 8 to both sides of the equation and x equal to positive 8. So yes, it's a quadratic equation. It should have two solutions, and this is an example where you have actually two repeated solutions, x equal 8 and x equal 8. Right here, you can notice that the squared part is not by itself, so the first thing you want to do is subtract 6 from both sides of the equation. So now you're going to have x squared is equal to 25. Now, every time you take the square root, you always want to make sure you give two solutions. So it's either x, when x is equal to positive 5, or x is equal to negative 5. So those will be your two solutions. You can write it as x equal to positive or negative 5. Next example here, same thing, you add 7 to both sides of the equation, and you have x squared is equal to 5. Now, if you take the square root, 5 is not a perfect square, and so you will write your answer as x equal to plus or minus the square root of 5. So every time you solve quadratics, you should have two solutions, except a case like this, where it's already equal to 0, and you will have one solution. Okay. Next example here, if you notice this squared part of the equation, there's a 4 attached to it. So the first thing we're going to do is divide both sides by 4 to get this squared quantity by itself. So when we divide both sides by 4, we're going to have x minus 3 squared is equal to 4. Now we're going to take the square root of both sides to undo the square. And now I'm going to have x minus 3 is equal to positive or negative 4. Positive or negative 2. The square root of 4 is 2. Okay, so now you need to separate this into two separate equations because you have to solve for x. So the first one will be x minus 3 is equal to positive 2, and then the next one will be x minus 3 is equal to negative 2. We're going to solve for x in both cases. We're going to add 3 to both sides here, and we're going to have our first solution, x equal to 5, and then we're going to do the same thing here. And we're going to have x equal to 1. So the two solutions will be x equal 5 and x equal 1. Okay. All right. Next one, in the last lesson we talked about, well, same thing. We're going to take the square root of both sides of the equation to get rid of the square. And if you notice, we have a negative under the square root sign. And remember, when you have a negative under the square root, you have the imaginary unit I. So I know my answer is going to have an I next to it. So this is going to be x squared is equal to the square root of 49. And the square root of 49 is 7. Remember, there's an I there. So if I take the square root here, that cancels. We're going to have x equal to plus or minus 7i. So anytime you have a negative under the radical sign or the square root sign, you know you're going to have the imaginary unit I. That's a complex number. Okay, so pause the video and try these two examples here. Okay, so right here, the first thing you want to do is get rid of this number that's attached to this squared part of the equation, so we're going to divide both sides by 10. Now that's going to give me x minus 7 quantity squared is equal to 44. We're going to take the square root of both sides to undo the square. And so that leaves me with x minus 7. And in this case, we want to simplify this, right? So remember, when you're simplifying square root, you divide by the biggest perfect square. And I can simplify this to the square root of 4 times the square root of 11. Well, 4 is a perfect square and 11 is not. So I'm going to take the square root of 4, and this is going to be plus or minus 2 square root of 11. Okay, so now we can separate this into our two solutions. The first one will be x minus 7 is equal to positive 2 square root of 11. The next one will be x minus 7 is equal to negative 2 square root of 11. So we're going to add 7 to both sides of the equation here. So plus 7. And the answer here will be x equals 7 plus 2 square root of 11. Make sure you do not add these 2 to the 7, because this 2 is multiplying the square root of 11. And then over here, it's going to be the same thing. We're going to add 7 to both sides, and my solution will be x equal to 7 minus 2 square root of 11. Okay, here, once again, before you take the square root, make sure there's nothing attached to the squared part of the equation. In this case, we need to get rid of the 1/2. So we're going to multiply both sides by 2. Okay, so that's going to get rid of this. This is going to divide out. And so all I have here is x plus 8 quantity squared is equal to 28. We will take the square root of both sides of the equation. That's going to undo the square, and we have x plus 8 is equal to, please simplify the square root of 28. I can simplify that to the square root of 4 times the square root of 7. 4 is a perfect square, so I have x plus 8 is equal to plus or minus 2 square root of 7. Now we just subtract 8. You can separate it into two different equations like we did here, or you can just subtract the 8, so over here, and you can write your answer as x is equal to negative 8 plus or minus 2 square root of 11. So I can say negative 8 plus 2 square root of 11, or negative 8 minus 2 square root of 11, but you can leave your answer like that. All right, pause the video, try this example. Okay, once again, your goal is to get the squared part of the equation by itself. And when you're undoing operations, you always want to add or subtract before you multiply or divide. So the first thing we want to do is add 16 to both sides of the equation. That's going to cancel out. And we have negative 2 times x plus 3 squared is equal to negative 32. Then we're going to divide both sides by negative 2. So we're going to have x plus 3 quantity squared is equal to 16. Now we're going to undo the square by taking the square root of both sides of the equation. And I have x plus 3. The square root of 16 is either positive 4 or negative 4. So x plus 3 is equal to plus or minus 4. In this case, you will need to separate this into your two different equations. So we have x plus 3 is equal to positive 4, or we can have x plus 3 is equal to negative 4. And then we're going to subtract 3 from both sides of the equation. We're going to have x is equal to 1 as one of our solutions. Do the same thing here, minus 3 on both sides of the equation, and we're going to have x is equal to negative 7 as the other solution. Okay, go ahead and fill out your notes, do your CY using an LCQs. Have a nice day.